Today we're going to go over two more methods for solving quadratics, completing the square and taking the square root. We're going to start with taking the square root. Now you've got to be careful with when you use this method. It does not always work. Like for example, if you had this problem, x squared plus 6x minus 2 equals 0, and you decide, oh, I'm just going to take the square root. Square root of 0 you can do, but how do you take square root of this? So you got to be careful with what you choose. So we're looking for perfect squares, plain numbers, and x squared only. So if you have this x term, you're not going to be able to take the square root. So let's run through some of these. We want to isolate the x squared. So we'll start by adding the 49. So we get 9x squared equals 49. So since we don't have the plain x term, we can do this. We're going to divide both sides by 9, and then we're left with a perfect square equals a fraction. Whether the fraction has perfect squares in it or not, it doesn't matter. You can take the square root of any number, positive or negative. When you take the square root, remember you get two answers. So the square root of this will be one answer. This is our variable, so we get one answer there. It's the numbers that you have to put the plus or minus in front of. Square root of 49 is 7. The square root of 9 is 3. When you're taking the square root of a fraction, you leave the top on the top and the bottom on the bottom. Here we subtract 15 and divide by 4. Now we have this weird fraction. It's not quite as nice as the last problem, but we're going to solve it the same method. Taking the square root of everything gives us x equals 15 has no pairs of numbers in it, so we cannot break it down, but that negative brings out the I. So we have plus or minus I radical 15, and we do know the square root of 4, that's just a 2. Now for this x plus 5 quantity squared, do not multiply it out. That's a quantity squared. We actually like that. So we'll start by moving everything away from it, adding the 49. Now we're going to divide by the 4. We got to get that thing that's squared all by itself. So the thing that's squared is there. It's isolated. And over here we have a fraction, which is really okay. We know how to take the square root of this. So we're going to take the square root of both sides. On this left-hand side, you get just what's underneath it. Square root and square are inverses. They undo each other. So we get x plus 5. On the right-hand side, that's where the plus or minus goes. Square root of 49 is 7. Square root of 4 is 2. Now what we have to do is we have to subtract the 5. The placement of this matters because this is adding or subtracting. When we subtract the 5, it belongs in front of the plus or minus sign. So we get x equals, that negative 5 comes first. Then we're going to add and subtract 7 over 2. Please put it in that order. This will help. If it has imaginaries in it, it'll just sort of force you to keep the imaginary second. Let's try this again to see what we get. We're going to add 8. So 5 times the quantity squared equals 8, and then we'll divide by 5. So x plus 1, still squared, equals 8 over 5. Now we're going to take the square root. So the left-hand side is x plus 1, 8. We need to take the square root of that. That's, of course, not a perfect square, so we'll use a little tree. 4 times 2, 2 times 2. Here's a pair of 2's. So the 2 is going to come out, so we get plus or minus 2 radical 2. Now the square root of 5, we cannot simplify, so it just stays that way. Now we can't have a radical in the bottom, so I'm going to multiply the top and the bottom by radical 5. And we're left with plus or minus 2 radical 10 over 5. And of course this side is still x plus 1. Now when you subtract the 1, put it in front of the plus or minus. Negative 1 plus or minus this fraction. Again, put the number, the plain number, in front of the plus or minus sign. So that method is very, very specific, and it only works in those situations where you have perfect squares. The next method we're going to do is called completing the square. And in this method, we're going to create our own kind of little problem, and then we're going to solve it like we just did, because that seems pretty easy to solve, but it doesn't always work. So we're going to create a problem where it does work. That's why we're going to complete the square. We're going to make something a perfect square, and then we're going to take the square root of both sides. So how do we make something a perfect square? The problems that you see here for 4 and 5, these are incomplete problems. These are just pieces of a problem. So here are the steps. We have to move that c value, that plain number, out of the way. It's basically in the way. So the equation should not equal 0. Also, something that's very important, that first term has to equal 1. We'll go through what happens if it doesn't. You're going to take half of the b term. So remember, it goes ax squared plus bx plus c. So we're going to focus in on this term. You're going to take half of that. Whatever half of that number is, then you square it, and then you add that number to both sides. Then we'll factor the left side. So let me just show you the first part of this. So here's our b term right here. It's a -4. So we're going to take -4, we're going to take half of that, you get -2. Now we're going to square -2. So -2 times -2 is a +4. If you get confused, just drop it, drop the sign, because we're always going to add. So 2 squared is 4, so we would add 4 to both sides. So let's try that again over here, number 6. Take this b term right here and divide it by 2. Oh, you can't divide it by 2? Then just do that. 5 over 2. Don't make this 2.5. Don't make it 2.5. Those numbers are hard to square. This number is very easy to square. Square the top, square the bottom. You're done. So if it's an odd number, just put it over 2. Half of 11, 11 over 2. Half of 15, 15 over 2. But if it's a number you can simplify, then actually do it. And then the next step after that is to take this left side here. I know we don't have a right side, but that's where it would be. And we're going to factor this out. And this is always the same pattern. We're forcing this to be a perfect square trinomial, actually. So the pattern is the letter, whatever the letter is. There's only one. The b is from the middle term. The first sign, okay? And then the number that you squared. We squared a 2. Not the sign that they squared, the number that you squared. And it's always going to be quantity squared. So that's why I write this, because then I can remember the number that I squared. So again, the pattern is the letter, the first sign, and the number you squared, quantity squared. It's a definite pattern, and these are very, very predictable. You do every single problem the same, which makes these usually pretty easy to do. So let's go through an entire problem. All right, so first of all, make sure that your a term is a 1. All right, so ours is. That's good. First thing, good. The next thing is make sure it's not set equal to 0. So this 7 is basically in the way. That's the place where we're going to complete the square. So we're going to subtract this 7. We're basically just moving it over there. So keep its spot, though. X squared minus 4x plus the blank. So the 7 created the blank. Over here we have -7, and we're going to add the same thing to both sides. You take half of -4. Okay, well, -4 divided by 2. Again, we don't really care about the sign, so you can forget about that. You get 2, and we're going to square it. That's the number that you add to both sides. It's an equation. You got to keep everything balanced, so add it the same to both sides. Now, the pattern is the letter, the first sign, the number that you squared, quantity squared. On this side, you just do what it says. Whatever it says. It's going to be an arithmetic problem. Just do what it says. So -7 plus 4 is -3. Now we're back to the problems from up above. We just take the square root of both sides. And on this side, we get x minus 2. And on the right-hand side, we get plus or minus. It's negative, so I. And I don't know the square root of 3, so it stays like that. Now we have to add 2, and remember, you snuggle that up in front. Now here, if you decide to do it in your own order, it's going to be wrong, because a complex number has to have the imaginary second. So don't just put it in your own order. Don't freestyle. Right? Put this in front of the plus or minus, please. All right, so what do we do if the a term isn't 1? It kind of depends on what it is. In this problem, if you look at it, every single thing can be divided by 2, and it works out perfectly, including the 0. So now we have x squared plus 16x minus 10 equals 0. So that takes care of the first thing. A has to be a 1. Now this 10's in the way, so we got to get this out of the way because that's our spot that we need to complete the square. So we get x squared plus 16x plus blank, and then we add 10 over here. And then we have the plus blank again. Process is the same. Half of b. Okay, 16 divided by 2, that's 8. Square 8, that's 64. We're going to add 64 to both sides. The left-hand side, letter, first sign, the number you squared, not the answer you got, the number you squared, quantity squared. Right-hand side, do what it says, 10 plus 64. Oh, except you know what? 10 divided by 2. I didn't divide by 2. All right. Forget this even happened. Whoop. It helps if you actually do what you say you're supposed to do. So I'm going to divide all these by 2 like I did, like I wrote, but I didn't do. So this is an 8x minus 5 equals 0. Very, very sorry about that. So we're going to add 5, creating that blank. X squared plus 8x, the blank, over here we get the 5. Half of 8. 8 divided by 2 is 4. 4 squared is what goes in the blanks. 8, oops, 16 is 4 squared. This is apparently struggle is real here, so we're going to add 16 to both sides. Letter, first sign, number you squared was a 4. Over here, 21. Square root. 21 doesn't actually have a square root, so that makes it kind of easy. So plus or minus radical 21. Right, because 21 is just 3 times 7. No perfect squares in there. And again, please, please, please move that 4 over so we get negative 4, then the plus or minus, then the radical 21. That was a little bit rough. All right, so again, first thing, is your A a 0? I mean a 1. It's not. Do all the numbers divide by that number? And they do. So we're going to divide them out. X squared minus 2x minus 4 equals 0. 4's got to go. X squared minus 2x plus blank equals 4 plus blank. Remember, you always add the blanks plus on both sides. 2 divided by 2 is 1. Remember, we don't care about the sign. 1 squared is still a 1, so we add 1 to both sides. Pattern. Letter, first sign, number you squared. On the other side, do what it says. Take the square root. So we get x minus 1 equals plus or minus radical 5. Move the 1 over here and put it in front of the plus or minus. 1 plus or minus radical 5. Now, you may find this hard to believe, but some people prefer this over factoring. So this next question is really just your opinion. Would you do x squared plus 6x minus 7 with factoring or completing the square? Well, I don't know. Are there 2 factors that multiply to give you 7 and subtract to give you 6? There are. It would be x plus 7 times x minus 1. So it factors pretty fast. So if it were me, I would factor it because I factored it faster than I can do completing the square. And for me, I would do it because it's faster. At least for that problem. Some problems, it's hard to factor, and maybe completing the square is better, easier. Now on this page, you try the problems, pause the video, and see if you did them right. You can do them one at a time, you can do them all at a time, but this is your chance to try and see how you do. So this one says, so pause the video, I'm about to do the problem. This one says to take the square root. So I'm going to subtract the 108. So I get 2x squared equals negative 108. Divide by 2. So we get x squared equals negative 54. Take the square root of both sides. 54. So this is 3 radical 6. So we get x equals plus or minus 3I radical 6. Remember, it's negative, so the negative makes the I. And this is a radical 6. This one, we're going to subtract the 13. Then divide by 2. Now we're going to take the square root. We break down 50. That's 5 times 10, and 10 is 2 times 5. So here's a pair of 5s that's coming out. And here's the radical 2 stays home. Then when you subtract the 5, put it in front of the plus or minus. All right, how'd you do? Did you find your mistakes if you made any? Now we're going to try completing the square. Everything starts with a 2, so we're going to divide by 2 first. Get the 4 out, creating your blank. Ooh. 3 divided by 2, that's it. That's how you do that, and you square it. So we're going to add 9 fourths. 9 fourths. Letter, first sign, number you squared. Over here, add these up. If you need the calculator, do it on the calculator. It's 16 fourths. Plus 9 fourths, it's 25 fourths. No decimals. We want fractions because we can take the square root of a fraction really well. So we have x plus 3 over 2 equals plus or minus 5 over 2. Move this over here, so we get x equals negative 3 over 2 plus or minus 5 over 2. Well, there's no radicals in these, so finish the problem. This is negative 3 plus 5 over 2, negative 3 minus 5 over 2. So this is 2 over 2, which is a 1. And this is negative 8 over 2, which is negative 4. When you get whole numbers like that, all that means is we probably could have factored it. There's no radicals, there's no imaginaries. We could have factored that thing, but we didn't. Last one for you to try. This one looks weird, but start the process the same. Get that 52 out of there. X squared minus 2x. We're going to have that blank. And then 4 minus 52 is negative 48. And we're going to have a blank. 2 divided by 2 is 1. 1 squared. We add 1 to both sides. Letter. First sign. Number you squared. Quantity squared. Right-hand side. Do what it says. Square root time. 47. Nothing goes into that. But we got an I. So we have plus or minus I radical 47. Now when you add the 1, please make sure it goes there. So it has to be 1 plus or minus I radical 47. If you put the 1 over here, that's no good. That's wrong. It's got to be first because of the I. So those two completing the square problems were the hardest two we've had probably. So if that was a little bit of a struggle, that's understandable. Try the homework problems. If you get stuck, just stop and bring your questions back to class or to office hours for some extra help.